You have such a big heatsink.
YAHRJ
Alright, I am very excited to show you my RF dummy load, which I made, and I'm mostly excited because for an hour project it took me a few weeks. Yeah, it took about a few weeks to figure out what heatsink should I use, and I decided to use this big boy, chunky boy. Basically just an RF connector bolted on a metal frame that is bolted on the heatsink, and we have a 250 watt resistor, and basically that's it. That's the whole project. This is usable up to UHF, so for 40 band. We shall take a look at it on the VNA and take some measurements. I have already calibrated the VNA on 1 meg to 500, so all the way to the upper UHF band. And as you can see, we can get it down to 1.2 something SWR, which is really good, only 1% reflected power. The resistor by itself is a bit on the inductive side. It's on the upper half of the Smith chart. And so we are capacitively coupling this smaller heatsink to it, so we can get it. You can get the SWR down. So yeah, very happy with it. Very happy with the results. Have a metal bracket that holds the second heatsink in place. Yeah, very nice. I have another wire here, which I intend to attach a power meter to, so we can actually see what power goes into the dummy load. And for that I'm using a very cheap amp meter, which I've taken apart and added some diodes to it. We'll actually take a look at that and see how this looks. So I have already soldered the so-called power meter to the dummy load. I've attached the quenching to it, and I'm trying to rectify the AC signal from the quenching with 3 series diodes, one N4148. Then we go through a resistor to limit the current going into the current meter, and just a capacitor to ground to smooth out the waveform. This should give us a reading, some reading. That's for 40, and on 2 meter band it should be a little bit higher on 2 meters. I suspect it's the diode not behaving properly in the upper frequencies. So now that we have a reading on our so-called power meter, we can try to calibrate it with some DC voltage, and we'll get an approximate power output of the radio transceiver. Let's try and do that. We can see the quenching is on the 4th line, somewhere between 2 and 4, closer to 2. Let's try to see what we get with some DC voltage. Connected a DC power source to the dummy load, and I'm outputting 12.2 volts DC, which should be like 3 watts RMS. And as you can see, it's up to the 3rd line here. So our little transceiver puts out more than 3 watts. We don't know actually how much, but it's more than 3 watts, and that's good enough for me. This is a future project. So yeah, adding the power meter reader to the dummy load, something I'll do in the future. But for now, this is it. This is all I wanted to show you. I'm really excited about it, and it's really usable. And I'm gonna call call it done. EAME. I finished another project. Maybe in the future I will try to find more suitable diodes for the RF signal rectification into DC, so I can get a better, more accurate reading on the power reading on the output of the transceiver. But for now, I'm really satisfied with what came of all this, and I'm calling I'm calling the dummy load project done, finished. It's usable, and I'm very happy about it.
YAHRJ